Chemistry of Life. This is Unit 1, Section 2. Specifically, we're going to focus in on water and solutions. In this section, we're going to go through a warm-up. We will look at key ideas. We will look at properties of water. We'll look at solutions, and then we'll summarize as well. The two major concepts that are in this lesson are properties of water and solutions, and so that's where our point of focus is going to be. The warm-up for this unit. You need to write what you think an acid and a base are, and why, and then guess if the following substances are acids or bases, and give a reason for your choice. So those substances are lemon juice, water, household ammonia, blood, soda pop, milk, antacid, and shampoo. And then while you're thinking about those substances, can you find any similar characteristics between acids and bases? Our key ideas for this unit. What makes water a unique substance? And then how does the presence of substances dissolved in water affect the properties of water? Properties of water. Water has many unique properties that make it an important substance for sustaining life. Most of the unique properties of water result because water molecules form hydrogen bonds with one another. They like to stick to one another. And then also when water freezes, it forms a crystalline structure. And the crystalline structure is due to hydrogen bonding. When it forms that crystalline structure, ice becomes less dense than liquid water, so ice rises on top of liquid water. It floats.
Water can absorb a large amount of heat without changing temperature. This property can help organisms maintain a constant internal temperature. It helps your body from getting too hot. The attraction of particles of the same substance, such as water, is called cohesion. Cohesion keeps water from evaporating. So water stays in a liquid state at ordinary temperatures, being natural temperatures. Water molecules also stick to other polar molecules. The attraction between particles of different substances is called adhesion. So cohesion is when water molecules want to stick to one another. Adhesion is when water molecules want to stick to other polar substances.
Cohesion is the force that causes liquid molecules to be attracted to themselves. This causes splashes to form droplets. Adhesion is the attraction of a liquid to a surface, such as how water spreads out on glass. The water molecules in a droplet of water are attracted to glass by adhesion, and they spread out. A meniscus is an example of a situation when adhesion and cohesion are competing. When adhesion is stronger than cohesion, a positive meniscus occurs, such as with water in a graduated cylinder. When cohesion is stronger than adhesion, there is a negative meniscus, such as mercury in a graduated cylinder.
So that concludes the properties of water. We're now going to get into solutions. A solution is a mixture in which ions or molecules of one or more substances are evenly distributed in another substance. In your body, many substances are transported throughout your cells as solutions of water. Dissolved substances can move more easily within and between cells when they are dissolved in water. Water dissolves many ionic and polar substances, but does not dissolve non-polar substances, which this becomes very important when we start looking at the makeup of the cell walls and also the cell membranes of organisms. Acids and bases. Some water molecules break apart to form hydronium and hydroxide ions. Pure water is made up of equal parts of hydronium and hydroxide ions. Acids and bases are compounds that change the balance of those ions. Figure 6 represents hydronium and hydroxide ions. It shows two water molecules, and it shows those two water molecules separating into the different ions. Notice that a hydronium ion forms when a hydrogen atom separates from water, separates from the water molecule, and it binds with another water molecule, giving an H3O+. A hydroxide ion has been formed due to the loss of that hydrogen atom. Acids are compounds that form extra hydronium ions when dissolved in water. Bases are compounds that form extra hydroxide ions when dissolved in water. When acids and bases are mixed, the extra hydronium and hydroxide ions react to form water. So think about the reaction that occurs with baking soda and vinegar. As that reaction occurs, the hydronium and hydroxide ions balance out.
Carbonated drinks, orange juice, vinegar, tomatoes, limes, and lemons all contain acids. Acids give these foods their sour flavor. Your taste buds respond to the level of hydronium ion in the food. The more acidic the food, the more hydronium ion present, and the more sour the food tastes. Hydronium ions are formed when an acid such as nitric acid reacts with water. In a water solution, this hydrogen ion frequently joins with a water molecule. The result is a hydronium ion, with oxygen bonded to 3 hydrogen atoms and a positive charge. Acids differ in strength. At the same concentration, strong acids produce more hydronium ions than weaker acids. This scale shows increasing acid strength for conjugate acids. Common acids include carbonic acid, used in making carbonated drinks, acetic acid, found in vinegar, and sulfuric acid, found in car batteries. Because they produce more hydronium ions, strong acids are particularly good conductors of electricity. Electricity is conducted by ion movement. This explains why a strong acid, sulfuric acid, is used in car batteries. The stronger the acid, the more hydronium ions are available to conduct electricity. Cleaners, including soap and ammonia, baking soda, and antacids, all contain bases. Bases give these products their slippery feel. Most bases are ionic compounds containing a hydroxide ion. Because these bases are ionic, they dissociate to some extent when placed in solution. Hydroxide ions can also be formed when a base, such as ammonia, reacts to remove a hydrogen ion from a water molecule. Bases differ in strength. At the same concentration, a stronger base produces more hydroxide ions than weaker bases. This scale ranks conjugate bases by strength.
pH and buffers. A pH is the measure of how acidic or basic a solution is. Each 1-point increase on the pH scale represents a 10-fold decrease in hydronium ion concentration. So pure water has a pH of 7. 7 is neutral. Acidic solutions have a pH below 7, and basic solutions have a pH above 7. The scale ranges all the way up to 14. Anything on the low end of the scale, 1, 3, 4, 5, 6, those would be acidic solutions. 8, 9, 10, all the way through 14 would be basic solutions.
The pH of a solution is related to its hydronium ion concentration. Small differences in pH indicate large differences in hydronium ion concentration. For instance, the pH value of apple juice is 2 units lower than that of coffee. However, it is 100 times more acidic than coffee. Each pH unit is a factor of 10 times the hydronium ion concentration of the next unit. A molar concentration of hydronium ions of 1 times 10 to the negative fifth gives a pH of 5. If the molar concentration of hydronium ions increased to 1 times 10 to the negative third, we would have a pH of 3. The smaller the pH, the stronger the acid.
The pH of solutions in living things must be stable. For a stable pH to be maintained, the solutions in living things contain buffers. A buffer is a substance that reacts to prevent pH changes in a solution. Usually buffers have an equal amount of hydronium to hydrogen ions. Our summary. The hydrogen bonding between water molecules explains many of the unique properties that make water an important substance for life. Acids and bases change the concentration of hydronium ions in aqueous solutions. The pH of solutions in living things must be stable.